So welcome back again to the next video of the previous series, and in this series we are just discussing about the electric charge and field. Okay. So in this video we will discuss about the Coulomb's law, in which if we have the two charge of maybe of the same polarity or maybe of the opposite polarity, so maybe the force of repulsion or force of attraction between them, so what will be the magnitude and what will be the direction of the force. So this can be find out with the help of the Coulomb's law. So in Coulomb's law, first of all, this Coulomb's law is applicable only in case of point charge. Suppose we have 2 point charge, and this is the point charge Q1 and here is the point charge Q2. So these 2 point charge may be of the same polarity or may be of the opposite polarity. If these 2 point charge having the same polarity, that means both charge having the positive or negative. In this case, these 2 charge will repel each other. And if these 2 charge having the opposite polarity, that means one that is the positive, another is negative, or first is negative, another is positive, in this case they will attract to each other. So maybe whatever be the sign of these 2 charge, that means between these 2 charge there is a force of interaction. So according to Coulomb's law, the force of interaction, that means the force of attraction or the force of repulsion between 2 charge depend on 2 factors. And here we are just assuming these 2 charge placed in air or vacuum, यानी कि इन दोनों चार्ज के बीच में जो मीडियम है वो अभी हम मान के चलते हैं कि ये एयर है या वैक्यूम है. So the force of interaction between these 2 charge depends on 2 things, on 2 factors. The first one, the force is directly proportional to the product of charge. That means F is proportional to Q1 into Q2. And in the second point, the force between them is inversely proportional to the square of separation between them. That means F is inversely proportional to R square. So when we combine these two statements, then we get F is proportional to Q1 Q2 over R square. And when we remove the sign of proportion, here we put a constant, and that is equal to 1 over 4 pi epsilon naught Q1 Q2 over R square. That is the force of interaction between the 2 point charge. Now here, what is epsilon naught? Epsilon naught, that is the permittivity of free space. Epsilon naught, that is the permittivity of free space. What is permittivity? Permittivity, that means the ability of a medium, the ability of the free space. That means because of the permittivity of the free space, so it is the ability of the free space to permit the passage of electric field lines. कि कोई भी जो free medium है, जो हमारा free space है, वो कितनी electric field lines को allow करता है, permit करता है. और इसकी वैल्यू होती है 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. Well, there the constant 1 upon 4 pi epsilon naught, and this constant having the value 1 over 4 pi epsilon naught is equal to 9 into 10 to the power 9 Coulomb square Newton meter square per Coulomb square. That is the value of this one. So this is the condition, this is the force whether these 2 charge placed in air or space. And when we change the medium between these 2 charge, ये मान लो हमने ये दोनों चार्ज किसी मीडियम इस एयर और स्पेस में न रखे, किसी और मीडियम में रखे. Suppose we just put in any kind of gas or in any other medium. So the force reduced by a definite amount of factor and the force change. So if medium change, and suppose the medium have the dielectric constant K, and the dielectric constant of the medium that is K, then the force reduced by the factor 1 upon K. जो force है हमारा वो 1 upon K times change हो जाएगा. That means then the force between the charge becomes F in medium is equal to 1 over 4 pi epsilon naught K Q1 Q2 upon R square. That is the force between the two charge when the medium is replaced by any other medium rather than the air or space. Now the next in this series, the next topic, here we use the term dielectric constant. So what is dielectric constant? Dielectric constant basically the ratio. It is the ratio between the two charge, between the force, the ratio between the force between the two charge when the charge placed in aerospace and when the charge placed in any medium. तो ये उन दोनों फोर्स का रेशियो है. लेट्स सी हाउ. तो now we will discuss about the dielectric constant. Dielectric constant, or it can also be known as relative electrical permittivity. Relative electrical permittivity. So suppose we have the two charge. Here is the charge Q1, here is the charge Q2, and these two charges are separated by the distance r, and if we assume the medium between these two charges in aerospace, so when medium between these two charges is air or vacuum, then what will be the force between them? So from the Coulomb's law, the force between them, so denoted by F naught, that is equal to 1 over 4 pi epsilon naught Q1 Q2 over R square. Equation number 1. And when we change the medium, between these two, यानी कि अगर हम इन दोनों चार्ज के बीच के मीडियम को एयर या वैक्यूम ना करके कोई और मीडियम किया जिसकी डाइलेक्ट्रिक कांस्टेंट K है, then what will be the force? तो if मीडियम चेंज, और जब मीडियम चेंज करोगे एंड सपोज द डाइलेक्ट्रिक कांस्टेंट ऑफ द मीडियम दैट इज K, देन द फोर्स बिटवीन देम बिकम्स F इन मीडियम इज इक्वल टू 1 over 4 pi epsilon naught K Q1 Q2 over R square. Suppose there is the 4 pi epsilon that is the permittivity of the medium. ये उस मीडियम की परमिटिविटी है जिस मीडियम में चार्ज रखे हुए हैं, एंड दैट इज परमिटिविटी मींस हाउ द नंबर ऑफ फील्ड लाइंस, हाउ द मीडियम इज परमिट द पैसेज ऑफ द इलेक्ट्रिक फील्ड लाइंस. सो व्हेन वी डिवाइड इक्वेशन 1 बाय इक्वेशन 2, अगर हम इक्वेशन 1 को इक्वेशन 2 से डिवाइड करें, देन वी गेट F नॉट ओवर F m that is equal to 1 over 4 pi epsilon naught Q1 Q2 over R square divided by 1 upon 4 pi epsilon Q1 Q2 over R square. Then we get F naught over Fm is equal to, that comes in the numerator, epsilon upon epsilon naught, and that ratio can be denoted as dielectric constant, or can also be named as the relative electrical permittivity. So from this statement, from this formula, you can define the relative electrical permittivity or the dielectric constant, that is the ratio. If you want to define in terms of force, so in terms of force, the dielectric constant can be defined as the ratio of the force between the two charge when placed in the aero vacuum to the force between the two charge when placed in any medium. And if you want to define the same dielectric constant in terms of permittivity, so that can be defined as it is the ratio of the permittivity of the medium to the permittivity of the free space. So that's all about the dielectric constant. Now in the next topic we will discuss when we talk about the force of interaction between the two charge. That means if the two charge having the same polarity, then they will repel each other. If the two charge having the opposite polarity, they will attract each other. So with the help of the Coulomb's law, we can only find out the magnitude. So, and when we want to find out the direction, what will be the direction of the force? If the force repel, then what will be the direction? And when the force attract, then what will be the direction? In that case, we have to use the vector form. So in the next topic, we will define Coulomb's law in the vector form. Let's see how. Coulomb's law in vector form. Coulomb's law in vector form. And in the vector form, we will use the coordinate. Suppose here is the x-axis, here is the y-axis, here is the origin. Suppose any charge q1 at a position vector r1, another charge q2 at a position vector r2. Just name that is the point A, here is the point B. So when we join q1 to q2, the vector leading from q1 to q2. So what will be the vector q1 q2? What will be the vector q1 q2? So if we recall the triangle law of the vector addition, so this is the vector, and on the head of this vector there is a tail of this vector. So in dono vector ka sum, that must be equal to OB. So from the triangle law of vector addition, OA plus AB, that must be equal to OB. So AB is equal to OB minus OA. That means vector AB is equal to R2 minus R1, and that can be written as vector AB is equal to vector R12. That means the vector leading from q1 to q2. तो ये जो वेक्टर होगा AB किसके बराबर होगा? R12 के बराबर होगा. Now we can find out the force between these two charges, how these charges interact to each other. So as we see here, these two charges having the same polarity. The charge q1 having the positive charge and the charge q2 having also the positive sign. So these two charges repel each other. So when we see the force on q1 due to q2, तो q1 पे जो फोर्स होगा q2 की वजह से, that means q2 repel q1, तो the force होगा in the direction of the line joining but opposite to the vector AB. That is the direction of the force on 1 due to 2. That is the force on q1 due to q2, that is the repulsive force. Similarly, if we see the force on q2 due to q1, तो q1 क्या करेगा? q1 q2 को repel करेगा in the direction of the vector AB. So that is the direction of the force F21. That means the force on q2 due to q1. So just see the force on q1 and the force on q2. So from Coulomb's law, force on q1 due to q2, that means F12. And what will be the F12? From the Coulomb's law, the force must be equal to 1 over 4 pi epsilon naught q1 q2 upon q1 q2. We are just seeing the force on q1 due to q2. So we have to see the distance, we have to see the vector leading from q2 to q1, and the vector leading from q2 to q1 must be equal to opposite to the vector r21. But when we say the magnitude of the vector, so if you remember the vector algebra, so if we have two equal and opposite vector, so the magnitude of the equal and opposite vector are equal. That means if we say the vector r12 that is equal to minus of vector r21. But when we say the magnitude, then the magnitude of these two vectors are equal. अपोजिट इक्वल अपोजिट वेक्टर का जो मैग्नीट्यूड होगा वो बराबर होगा, लेकिन जो उनकी डायरेक्शन होगी वेक्टर की वो कैसे होती है, अपोजिट होती है. सो हियर वी यूज वेक्टर r21 of magnitude of vector r21 square, and this force, what will be the direction of the force F21? The direction of the force F21 is directed from Q2 to Q1. That means the vector leading from Q2 to Q1. So that can be represented by the unit vector in the direction of R21. That is the question number 1. Similarly, when we see the force on Q2 by Q1, force on Q2 due to Q1, that means the force F21, and also from the Coulomb's law, 1 over 4 pi epsilon naught Q1 Q2. What will be the separation between them? That is R12, and we are using the magnitude, so that becomes the magnitude of R12 of whole square. And what will be the direction of the force? When we see force F21, the force is directing from Q1 to Q2. That means we are using the unit vector leading from Q1 to Q2. So in the direction of unit vector R12. Now when we see equation 1 and 2, now just recall the vector algebra. Okay, when we see the two equal opposite vectors are equal and opposite to each other, but the magnitudes are equal. So when we talk about the unit vector, the unit vector of R12 can be written as the vector R12 upon magnitude of vector R12. And we know the magnitude of the opposite vectors are equal, so we can write R, the magnitude or of R12 is equal to the magnitude of R21. It can be written as vector R21 upon the magnitude of R21. And when we see the vector R12, the vector R12 is opposite to the vector R21. So the unit vector R12 can be written as vector R21 upon the magnitude of R21, and this whole quantity becomes the unit vector R21. So here unit vector R12 is equal to negative of unit vector R21. Now you can use this identity either in the question 1 or in the question 2. So just take either equation. So let's see from equation 1. From equation 1, F12. F12, that is the force on 1 due to 2, and that is equal to 1 over 4 pi epsilon naught Q1 Q2 over R, magnitude of R21 square. And that can be written as we know कि दो वेक्टर इक्वल अपोजिट वेक्टर का मैग्नीट्यूड बराबर होता है. सो इन द प्लेस ऑफ दिस वन वी कैन आल्सो यूज द मैग्नीट्यूड ऑफ वेक्टर R12. So that becomes the magnitude of R12 square. And the unit vector R21, as we find out here, the magnitude of R vector 21 is equal to opposite to the magnitude of opposite to the unit vector R12. यानी कि R21 का जो यूनिट वेक्टर होगा वो किसके बराबर होगा? अपोजिट टू द यूनिट वेक्टर R12. So here R21 can be written as negative of R12, and the whole quantity can be written as from equation 2, that is equal to F12 is equal to negative of force F21. That means two charge in the Coulomb's law vector form, the two charge repel to each other with the equal and opposite force. That means this charge acts at opposite equal force in the direction, while this charge also acts at the same force but in the opposite direction. So when the two charge of the same polarity separated at any distance, so they will exert equal and opposite force on each other. Now in the next topic we will discuss, if we have a bunch of charge, if we have a multiple charge, and we just find out the force on a particular one charge, then what will be the force? So in the next video we will discuss about the force on a particular charge due to the other one, and how the presence of other charge does not affect the force between any two kind and between any two charge. So this topic we will discuss in the next video. So that's all for today. Thank you so much.